Okay, good morning everyone. How are you doing today? Welcome to a stream. Today's stream is on circular gravity, a topic we were discussing on Patreon in a post that I made a couple of days ago. Basically, we were going through some old posts. I'm just going to try and find that post now. Here we go. Basically, a blog article that I wrote a few years ago, actually, 2013, using Game Maker's inbuilt physics system. Very simple article, but I figured I never had a chance to turn this into a video, so I thought I'd come as a stream today, and we'd go ahead and implement circular gravity, and I can answer any questions while I'm here, while you're here, and we can go through how it works and what it looks like. So, with that said, I'm going to put that on my second screen so I can cheat and refer back to the code. Anyone who's watching this in the future on YouTube, this video will be archived. It'll be on Patreon first with the files, so if you want to download the files for this project, you'll find a post on my Patreon page. It's patreon.com/rm2kdev. And then probably a week later, this video will come out on YouTube for everyone to view completely free. So if you want to get early access, just consider jumping onto Patreon and helping support the channel in that way if you can. With that said, guys, let's get started. So, of course, I've come today, excuse me, with absolutely no plan of how I'm going to do this. I figured we just go at it. So let's call this SPR Planet. I'm going to edit the dimensions of this image. We're going to make it say, I don't know, let's make this say 100 by 100. It was already done. Just press apply. So we're going to get a larger image. I'm also going to center align that image. Then I'm going to edit it. And let's just zoom out just one point there. I'm going to take just a futuristic green, one of those colors, and I can't remember how you do it. There's no circle tool in this one, is there? There's rectangles. There's no circles. Oh no, there is circles. Here it is. I'm just going to go corner to corner and make this kind of like planet-like shape. There we go. So we have a planet. Again, graphics aren't my strong point, so I'm sorry if my graphics offend anyone. Hopefully they don't. Let's call this RM Space. That'll be our space room. By the way, are the volume levels good, guys, in chat? Alien Head. Asian guy of today. Love your name. I'm going to create an object. This object is going to be called obj_planet. And let's go ahead and give it the sprite. Thank you, Asian guy. It sounds so bad to say that. I'm sorry. Let's go ahead and then place some planets in the room, and these are going to represent our circular gravity planets. I'm gonna put a few like that. Put one like here. Put one like there. One like there. You know what? That'll do. We can also increase the room size, make it like 2,000 by 2,000 on the room. And if we zoom out a little bit, credits to my good friend. I can never remember it. Let me go onto my Patreon and remember who I was talking to again. I said in the last video that you can hold down the Alt key and then just click and Sherm, yes. Credits to Sherm for teaching me this trick of just holding down the Alt key and dragging the mouse around to put down multiple objects. I feel like an idiot. They're all the same size at the moment. Just put them on here. These are just planets, you know. I'm just gonna make some random planets in the room. Then what I'm gonna do is I'm gonna come over here and create a sprite again. Now that one was 100 by 100. So this time I think we'll go with, I don't know. Let's make it 16 by 16. Oops. We need to edit the dimensions first of all, and make that 16 by 16, and then click apply. And then I'm going to edit the image, and again we'll do the same thing with this little circle brush. I'm just going to draw out a circle, corner to corner. This is going to be our player, our character of sorts. And I'll just middle center align that image as well, so the offset of the sprite is in the center as well. I'll go ahead and name that SPR Player. SPR_player. There we go. So now we have a player and we have some planets. Let's create an object. Let's call this obj_player. And I'm going to give this one the player's sprite. Top Ice 1, Level Max Jelly 2 Master Pro XXL. Welcome. Good to see you again, sir. I'm going to jump into the space room and I'm just going to drop a player object just like right there. So now you can see kind of in context, you know, if we were zoomed in on this, you know, I mean, the player's probably even just a little bit too big. But, you know, we'll get a good visualization of what this looks like. So the other thing I'm going to do is I'm going to go to my viewports and cameras settings in the room. I'm going to enable the use of viewports. I'm going to enable viewport 0. I'm going to set its width to 1280 by 720. I'm also going to set the viewport properties to 1280 by 720. So that way it's not pixel doubled. And then I'm going to tell it to follow the player. Now let's just quickly run our game, make sure that everything's set up correctly. We can see our player in context with the space, the camera's aligned correctly, etc. Okay, and it is, however, it ran on my second screen. So one thing I see that's incorrect is the player is in the corner. We don't want that. We need to make sure that the player, the following settings are set as 1280 by 720, and that will basically make sure that the player, its position can be centered in the viewport, meaning that the borders from where we follow. No, Asian guy, I just fixed it. Meaning that the borders keep starting on my second screen. It's going to be a pain. But yeah, now you'll see the character, the player is in the middle of the screen. Just by changing our horizontal and vertical borders. Basically, the horizontal and vertical border is, if you imagine where the camera is, it's kind of a border in which you say the player can move around before the camera scrolls. So that way you can get to the end of the screen, then the camera will scroll. You know, it's just a way of adjusting how the camera responds. So there we go. We've got the player done. We've got the planet done. Now, the other thing I'm going to do is I'm just going to move the player a little closer to these planets. Just so that we can test this circular gravity. Now, let's get started doing our gravity code. We'll jump into a planet, and we're going to add a create event. In our create event, I'm also going to zoom up this window for you, so let me just... oh, crap. Crap, cancel. Stop. Push the wrong button. I think it's F7? F8. No, it's F8. We're going to say initialize the planet. So, first of all, we know that the planet is 100 pixels wide, 100 pixels wide, 100 pixels tall. So the radius is going to be half of that, which is 50. So we'll say planet radius equals 50. Sitting games, so to reach the end of the screen, will freeze, then a side scroll to the next one. Yeah, sort of like that, but not quite. It's more just like the border of the scrolling. It'll only begin scrolling your character when they get to the end. The Zelda style scrolling from classic Zeldas is a little more complicated, but not too much harder. You just have to use a following object. I'm also going to add a draw event, and I'm going to just say debug draw here. This is going to be for drawing some debug things out to the screen, and I'm just going to do a draw circle, and we're going to do it at the X and Y of this planet. The radius is going to be, what do I call it? Planet rad, and outline will be 1. The other thing I'll do is I'll just say draw set. Actually, no, I don't need to do that. It'll be white by default. So the radius is already set, but if we multiply this by 2, it should draw a circle around each planet that is twice the width twice the radius of the planet, which basically should make it twice as big. So it should be 50% the radius on each side, which it has done. However, I need to draw the planet as well. Draw self. There we go. Let's try that. Excuse me. Alright, let's just have a look and see. I'm sorry about the game appearing on my other screen. I'm going to have to keep dragging it onto the main window over here. It's because I've got a bunch of screens hooked up right now. So there you go. You can see the planet, and then 50% of the planet's width is the equivalent of 50%, of the distance between this side of the planet and then this circle. And then from the other side, again. So basically, this circle on the outside of the planet is twice as large as the planet itself. Alright, so 2 times, probably not big enough. We might need to go 3 times. So let's multiply it by 3. This is going to be the the radius of our gravity effect, meaning if our player is within that circle, we're going to apply the circular gravity to the player to pull them down to the planet's surface. That's better. So now, have a look at this. You'll see we have a little bit of overlap in some of these planets. We probably even want a little more overlap, to be honest, because that way, if you imagine the player going through, they're going to sort of come through here. They're going to hit into this planet first. They're going to get pulled down to the surface of that one. But if there was an overlap between these two, you're going to have the forces of each planet pulling against the player object. So you might get this cool kind of swervy effect through the planets as the ball travels past. Alright, so that's just some debug code so that we can sort of visualize what our gravity is going to do. We know that our gravity radius is going to be 3 times planet radius, so let's just update our code. Let's call this gravity radius, and we're going to call this planet radius multiplied by 3. That's going to be our... Actually, you know what? Screw it. Let's multiply it by 4. Then what we'll do is, instead of drawing this math, we'll draw our gravity radius. I'm going to paste that in there. Exactly, Asian guy. It's going to curve through. So now we have a gravity radius and a planet radius, which is just to define, you know, the size of the planet itself. Now, next thing we need to do, and I apologize if I get any of this wrong. I haven't played with Game Maker Physics in a long time, but we're going to do our best. So we need to come over to the object and we need to tick the user's physics box. And then let's come over here into the physics window. We're going to set our density to 0, which means that it should have no gravity. And then just modify the collision shape and make sure that it is following the circle, which it's not. It's currently set as a box. Let's change that to a circle. The radius has automatically been set to 50 for us. So we can see the radius is exactly 50, which gives us a circular surface. And then I'm going to close that window because I don't think we need it anymore. So that is the physics settings for the planet. Let's go and have a look at our player now. And we're just going to tick the user's physics tab, tick box, sorry. We'll come over to the physics. We're going to set the density to 0. Which basically, if there's no density, then there's no... Actually, that might be wrong. We might need to have density. Sorry. We'll check this in a second. We'll go modify the collision shape. We'll change it from a box to a circle. And then we will close this one. And then we can close this tab here as well. Now, I think with the densities... Yeah, we'll probably do that after top ice. Just because, right, I just want to get the physics working first, and then we'll come back, and then we'll procedurally generate the sizes of the planets. And we'll draw them using the Game Maker draw commands. And that way, I think we should be able to get each planet to having their own different gravities. But let's just get the mechanics working first. So our player now is using physics. The circular collision detection is set on. Let's go back to our room. And I cannot for the life of me remember where the physics settings are in the new Game Maker for the rooms. Oh, there they are, room physics. So if you collapse down these menus here, you'll have this room physics option. We're going to tick enable physics. We're going to set gravity X to 0 and gravity Y to 0 as well. What this means is that there's no gravity. We're in space. We don't have any gravity pulling all our objects down. So with the physics options set, let's run our game. And let's have a look and make sure that everything stays exactly where it is. We basically want to have physics running, but we also want to have it not doing anything. Is kind of the goal here. Alright, so I can see already it is working correctly. Everything has stayed exactly where it is. And by increasing the radius of the gravity for our planets, we've also got these nice little overlaps between some of them as well, which will adjust the way that our player traverses through gravity. So, next up, I just want to find my notes quickly. There we go, found it. So when you make the procedural generations, they'll maintain the physical properties. Yes, they will. They should maintain their physics properties because we're just gonna adjust. Well, actually, that's a good question. I don't know. We'll find out. We'll find out later. So now what I want to do is I just want to test our movement. Let's test our ability to move. So I'm going to create a step event on our player. And I'm just going to comment this out and just say test movement, you know, test movement, like that. What we're going to do here is we're just going to say physics, I think it's physics, apply force. We're going to apply the force from X and Y, and we're going to apply it in the direction of, say, X plus 10, Y plus 10. Let's see if that works. It should work. I just want to see if we can get our player moving using the physics system. Should just move in one direction, but using physics. Alright, here we go. And of course, it's not moving. And I believe that might be because we set the density to 0. So I thought actually we might need to turn this density back on. Let's set the density just 0.1 for now. Actually, let's set it to 1. Let's just try that. Sorry about the build times, guys, as well. My new computer is a little bit slower than my old computer. It takes a little bit more time to build stuff. When I record the videos, I'll try to edit the build time out. There we go. Right, so yeah, okay, so it is working. It just shot off the screen too quickly for me to bring it on the screen. So let me just lower these values here to say, oh, come on, mouse, to 1 and 1. Maybe you'll be able to see it. Excuse me. Yeah, so all objects in the physics world need to have a density in order for them to move. Close Discord. Oh, it's eating up my CPU time. Yeah, I know. No, you're not going to be able to see it. Yeah, so it is moving. There we go. It moved. All right, cool. So that code is effective. It is working. It's good. It's fine. Actually, you're probably right. I should close Discord. Let me kill it quickly. Get some CPU time back. Oops. There we go. All right, Discord's gone. So we've successfully been able to move the planet. We've given it a density of 1. Let's go ahead and come to our planets this time. Now, let's give the planet just a much higher density. We'll give it a physics density of, say... Well, actually... Yeah, no, we'll give it a physics density of, say, 100. Very dense kind of planet, you know? It's just way heavy. Alright, so now that we have the physics density set up, we can go ahead and begin implementing circular gravity. So with our planets, basically the way this is going to work, each planet is responsible for applying the gravity pull. We're going to call it a gravity pull. We're not going to go in reverse. We're not going to tell the player to move towards a planet. We're going to tell the planets to move the player towards them. Because if we do it in reverse, we can kind of use a double loop where we can go through each planet and each player in the world, if there's multiple players, for instance, and then automatically pull the player towards the planet. So we're going to do it in reverse. By doing it in reverse, it means that we can still have player control in our player object without having to worry about the physics of dealing with the planet itself. So we'll go ahead and we'll create a step event in the planet this time. And I'm going to call this one here, give it a name, process gravity. Right, so that's going to be the name. And what we're going to do is we're going to loop through each... Hang on a minute. We're going to do it like this. Alright. Discard what I said. We're going to create another object. Sorry, guys. I know. Unscripted video. I apologize. We're going to create another object, and we're going to call this obj underscore controller. I just want to separate my logic out. I just thought about it. Then we will put the... excuse me. We'll put the controller... Gravity with no vowels. Did I spell it wrong? We'll put the controller on the map, and then in the controller, we're going to do this. We're going to go add a step event. So now the controller has a step event. And we're going to say process gravity. There we go. Process gravity. We're going to do it in the controller because it kind of separates it out. Leaves our logic for both our player and our planets to be separated. So we'll say with object planet, because we're going to say, remembering that the with event is almost like a for each. In any other programming language, it's a for each. If there's multiple planets in the game, it's going to go through each planet, and it's going to run this code one time for each of those planets. The first thing we need to do is determine the... we need to determine whether or not the player is within... whether or not the player is within the planet's gravity radius. So in order to do that, we need the distance to the player. So we'll say distance. We're going to say it's going to be equal to point distance. And the distances we're looking for are from our current X and Y to our object player.x and our object player.y. That's going to give us the distance to the player. Then what we need to do is we need to say whether or not the distance is less than our gravity threshold. So I'm going to say if distance is less than our gravity radius, which is basically our gravity threshold. If we are within the radius of gravity's effect, then we need to pull the player down to the planet. So how far down and in what direction are we moving the player? We need to work out the direction vector. So we need a direction vector, which is going to be point direction. Right, now point direction is going to take our current X and our current Y to the object players.x and the object players.y. Right, now that we have a direction vector, we can calculate a length towards the player. So I'm going to say dx, this is just direction x, is going to be length direction x. That's the function. Length direction x. I'm going to use a value of 150, just arbitrary number, and it's going to be in the direction of dir, which is our direction vector to our player. I'm going to do dy, and this needs to be length dir y at 150. And of course, if we're not in the radius of the gravity for this planet, then our dx needs to be 0 and our dy needs to be 0 as well, because we don't want to have an effect. Then what we'll do is we'll say with the player, so we'll say with object player, object player. So with the object player, we want to apply the physics force, physics apply force, from our current, so from our player's current, oops, I messed up that. From our player's current X and current Y to our dx and dy, which is our direction vectors, which is going to be in the planet. So I'll say other.dx, other.dy. Remembering that now, because we're in the scope of player, other is actually referencing this object. So we need to have that, otherwise it'll say that we don't have dx and dy within our player. And in theory, I think this might have an issue, but we'll find out. I'm going to run the game and let's see if we have gravity to our player. Sorry, gravity to our planets. It may currently push us away, but we'll find out. Yeah, so currently it's inverted, but that's still kind of cool. Basically, it's pushing us away from the planets. So, because we've gone from planet to player, the direction vectors are incorrect. They're inverted, basically. So when we get into the gravity of a planet, we're getting bounced away. Kind of cool if you wanted to make a gravity pinball game or something like that. Just do it in reverse. So yeah, basically, these lengths and directions need to be inverted. So I'm just going to negative those numbers to invert them. And I think, maybe, I might be wrong. We'll find out. But that should, I think, invert the direction vector, which should pull them down to the planet. Antimatter planets, yeah. On collision, instance destroy, that sort of thing. Okay, cool. So, now, we're getting pulled into the gravity of the planet, but we're not colliding with the planet's surface. So, to simply fix that, all we need to do is create a collision event with from the player to the planet. So we'll just add a event in here. And I'm just going to add a collision event with the planet. And I'm just going to say, make sure you collide. And then I'll just, I don't know, just leave the comment in there. That should be enough. And if we run, I think, I hope, we should have working circular gravity. Again, sorry the build time, and it's opening up on my second screen. But yeah, now we have working circular gravity. It has pulled the character down to the planet's surface. Probably pulling with a little bit too much force. We can adjust those variables quite easily. I'm going to drop that from 150. Let's just make it 50 actually. Make it 50. Oops. Make that 50-50. Should make it happen a little bit slower. Now, the next thing we need to do, every time you run the game, the stream lags for some reason. Or does it really? That might be... this computer is actually... It's a really great computer, but it's not very heavy on the resources, we'll call it. It's a laptop. Yeah, I'm pretty much maxing out my CPU. Actually, you know what I could do? Let me just turn the CPU up to... from best mode to best performance. There we go. Now I should have better performance in theory. We'll see. Let's see if that helps. I just changed my CPU from mobile mode to more performance mode. Alright, so we have gravity working, we have a collision with the planet working. The next thing I want to do is make it so that we can control the player. And the way that we're going to do this is we're going to use like a dragging thing. So when we mouse left down, when the mouse left, actually, you know what? We'll do this in a step. Will we do it in a step event? Yeah, we'll do it in a step event. We're not going to test movement anymore. We're going to process movement. Process movement. So we'll say if mouse check button, and we'll do MB left. So if we're left clicking or tapping, if it's a touchscreen device, then we will say, what are we going to say? We're going to say, let's add a create event. Hang on a minute. This is probably the wrong way to do this. Yeah, this is the wrong way to do this. Sorry, my bad. We're going to use the mouse left pressed, mouse left released. So we'll do mouse left pressed, mouse left pressed, global left pressed, sorry. Change event to a mouse global left pressed. That's the one. Difference between left press and global left press for anyone who's watching. Left pressed means that you've actually clicked on the object, and a global left press means that just anywhere in the room the mouse button was pressed. Even on an object, it doesn't matter. Just anywhere in our game we have pressed the left mouse button. So with our mouse left pressed event, we're going to set a flag. And in our create event, we'll just say init player. We'll say is left pressed equals false. Equals false. Alright, so in the global left press event, we'll say press left. I know this is seeming a bit weird. We'll just say is left pressed. And we're going to say it's true. Yes, the left button was pressed. We're going to do the same thing for released. But in the released one, we're actually going to process some kind of physics. So we'll say in the global left released, we're going to say depress left. And then we'll say is left pressed equals false. Actually, do we even need this is left pressed thing? Yeah, I think we do. I think we do. Right, so in our draw event, let's just get this started first. We'll say if left is pressed, draw, self, and line. So if is left pressed, we are going to say, oops, we're going to say draw line, and the line is going to be from its current position to the mouse's position. Right? So we're going to basically get a line from, hey, XD Game Studios, welcome. Good to see you again. So we're going to say if the left button is pressed, we're going to draw a line from the player to the mouse's position. And then we also need to draw itself, because if we're not drawing itself, we're not going to see it. So let's just confirm that that works. When I click the mouse button, we should get a line that shoots out of the player to our mouse button. Neil Kroll, hello! Welcome to the stream today. Alright, so the build is done. Alright, there we go. So now, if I bring this over here, if I left click, you'll see we have this kind of shooting vector thing. This is kind of like our aiming thing. Alright guys, just give me 2 seconds. I just want to have a quick glass of water. 1 sec. Okay, I'm back. Sorry about that. So yeah, we've got this like launching vector now, so we should be able to like pull back away from our player and then launch them off into the distance. So now we're drawing the line when the left button is pressed. When the left button is released, now we can apply a physics force. What is the physics force that we're going to apply? Well, that is the distance from the place that the mouse was released to the player. So first of all, we need the distance. So we'll call this mouse dist, and we're going to use point distance. Point distance. It's going to be from the current player's X and Y to the mouse's X and the mouse's Y. That is our distance right now. Then what we need to do is we need to make sure that that value is an absolute value, meaning it is above 0. We talked about this in the last video, the concept of absolute values. So the mouse, because it can move all the way around the player, actually, I think it already is a distance. What am I talking about? Yeah, it already is a distance. I don't know what I'm talking about. Let me just check that. Let's open up the documentation and see what it returns. I think it already is absolute. Let's have a look. Alright, well the documentation is wonderful because it doesn't say. Let's just see first of all. If it is absolute, we don't have to worry about it. Alright, never mind. Forget everything I said. Oh man, I'm sorry about the lag when I run the game. I'm gonna try and set up my PC, my old PC, and get it connected to the monitors as well, so that when I do these streams, I can use my actual desktop PC. Because right now I'm using a tablet laptop connected to a dock, connected to screens. Alright, so we have mouse distance now. Then what we need to do is say, what do we need to do? We have the distance. Let's calculate an X and Y vector. So we'll say dx, which we'll call it Vx, equals length direction X. The length is going to be mouse distance. That's how far away we want it to go. And the direction, we need the direction of the mouse. So we'll call this mouse dir, and we'll change the word distance to direction. Point direction. That's going to give us the direction as well. So now we have the distance and the direction. We need to create an X vector and a Y vector to represent our directions in, I guess this is standard XY coordinates. That might be called Cartesian coordinates, I believe. So we have a distance, a direction. Now we have an X vector and a Y vector. We should be able to physics apply a force. Actually, no, maybe an impulse. I think it's an impulse. We'll apply an impulse. We'll try them both. We'll see what happens. That's the point of game development. You know, you don't have to know everything. You just got to try all the different things and see what works. So we're going to go from our current X position and our current Y position. We're going to go to our vectors X position and our vectors Y position. And in theory, if it worked, when I release the mouse, depending on how far away from the character we were, we're going to get that impulse in the direction, and we may need to do it the opposite way as well. Otherwise, it'll come towards the mouse. We'll see. All right, so the game's running now. There we go. So now we've got this. So now it's just pulling towards the mouse, and the planet gravity is probably a little too on the light side now, because we're not getting much of an effect. But you can see we're getting this cool like rolling. Now if we hit a planet, not only will we be affected by the planet's gravity as we're being pulled back down to it, but we're also orbiting. And we can enter an orbit if we get the right launch vector. We should be able to enter an orbit. We have a sort of orbit going on there. The other thing that I'm noticing as well is that my mouse pulls are probably a little too strong. Let's adjust some of these variables and get it right. So we know that the distance right now is how far we're doing it. So let's divide it by 2. Let's make it half as strong so that our launching is not as strong. The other thing we're going to do is we're going to invert our direction. So that way it's almost like we're like a pool cue. You know, we pull back and we let go and it shoots off in the other direction. And then with our planets, let's go ahead and increase our gravity values. What did I do? I did that in the controller. Let's increase our gravity values from 50 to, say, 100. It was 150 at the beginning. We may even actually go back to 150. It just depends on what we feel like, I think. What feels good when we're playing the game. And sorry if the streaming is loading every time I run the game. I'll try and sort that out. Yes, top ice Juan Level Max Jelly 2 Master Pro XXL. You are correct. It is absolute. Alright, let's pull this off planet. So now it should be the opposite way. I think. Is that right? I can't tell. Let me get into some open space. Yeah, it is. Oh shit. I can't retrieve the ball that's gone off the screen. Pinball machine. Exactly. Actually, we should put a button in here to reset the game. Hello, Damien. Welcome to the stream today. All right, let's have a look. All right, here we go. Let's try and exit the planet's gravity. There we go. We have orbit now. Well, we're actually just circling the planet, but can we get an orbit? Oops. Actually, I think there might be a slight issue with the way. Never mind. Never mind. Actually, what I want to do is one of these is the wrong way. You know what we could do? We could just leave these as they were. Forgive me just for experimenting here, but let's go from. Let's invert this around. Let's change this to other.dx. No, sorry. What am I doing? That stays the same, sorry. I need to be in the player object. Let's adjust these to go from players x to vx. That's divided by 2. Instead of inverting the direction, let's invert the vector. Because it should have the same effect, but it seems like something weird was going on with the left and rights. Just from that little debug. Is anyone else getting stream lag in the stream when I build the game? Alright, let's have a look at this. I feel like I had you on stream once upon a time after playing a game or two of Left 4 Dead. Asked with wonder and reverence if you make games in RPG Maker. If so, hey -M, I don't remember, I'm sorry, but I used to make RPG Maker games. That's better. Now it's feeling appropriate. Everyone's getting the lag. Alright, sorry about the lag, guys. I will do my best to figure something out with regards to that. So there we go. We have appropriate circular gravity now. I'm pretty happy with that. There you go. Oh, no. Ah, crap. It's gone off the screen. I need to... Sorry. I'm just having more fun playing it than actually doing anything with it. So, we have this idea now of basic gravity happening. The thing that we talked about earlier was changing the gravity for each planet. I mean, it's as simple as adjusting the sprite and changing the planet radius. So, I mean, technically speaking... I think we could just pick a sprite and then... Nah, we won't do that. That's lazy. I mean, planet radius gravity radius is automatically set up by the planet's radius. So we could just simply randomize the gravity radius. We could just say that it's the planet radius plus random 400. So it's either going to have no gravity or a lot of gravity. Stop the ball from moving when it hits the ground. It probably would be kind of hard to do that just because we're using the physics system to achieve this. But alright, now let me bring this back over here. Now you'll see that every planet has its own amount of gravity. We're getting pulled and pushed into all different sorts of orbits. So you see these two here competing. They're competing for the gravity of the ball. And the ball is kind of getting stuck in its own little orbit over here as these three planets are pulling and pushing until we apply a force to sort of exit the gravity, so to speak. And obviously the bigger planet is going to have more of an impact because the ball stays within the gravity of that planet more. Anyway, that's really cool. Sorry guys, I go quiet when I'm just watching and just inspired by the gravity. There we go. We've entered a figure 8 type of orbit. That's really cool. I like that. Obviously, you could put this into some sort of... I've seen a few games recently use very similar mechanics to achieve this kind of thing. You know, you could have players walking around the surfaces of these planets. Not players, sorry. You could have asteroids, you know, all sorts of objects. It just depends on what you want to put in. Obviously, we've entered a point of space now where there's no gravity, and we just move until we get into some planet's gravity. And the other thing we can do, now that we have this... can you not make the gravity stronger or weak? Yes, that's what I was thinking we could do. So, the gravity radius here right now is a number that is 50 plus 400, so it's quite high. We could change this as well to say gravity underscore pull. Now remember that we're using numbers up to, I think it was 100. So if we kind of divided this down, we could just say gravity radius and then divide this down by, say, I don't know, could you make smaller planets orbit bigger planets if they don't have gravity? Yeah, you could do that. The code is exactly the same. Divided by 10. So we'll create a gravity pull effect that is based off of the gravity radius for each planet. And then instead of using our own... What did I do this? In the controller, instead of using 100, we're going to use the gravity pull effect. That's going to tell us how much it is. And the other thing I might do, just so we can tell, I might add a draw event. Oh, I've already got a draw event. And I'm just going to draw some text. Draw text. This is just for debugging, you know. Draw it at the X and Y, and we'll draw the string value of the gravity pull. So that way we know, you know, what is the gravity pull effect of this planet, so we can see it. Oops, I'm missing a bracket. Let me just add another bracket on here. Sorry, my dog's playing in the background there. It's okay. So there we go. So we should be able to see what the gravity pull is now of each planet when we run. Okay, let's just pull this over here. There we go. So now you can see bigger planets have a bigger pull, smaller planets have a smaller pull. So even if we entered into that planet's atmosphere, I guess you call it, gravity sphere, oh, there we go. This one's fighting it the most, and that one is 1. Oh no, this one's pulling it off that one, because, I mean, if we turned all of the planets into gravity into gravity-controlled objects where they were each reacting against each other, we'd probably just end up with a mess because we wouldn't be able to balance the physics in such a way that they would really play nice with each other, not without wasting a lot of time just messing around with numbers, you know? So yeah, let's put this planet into a bigger orbit. Alright. These two are fighting against each other. 42 versus 44. I'm just trying to figure out what's actually happening with these numbers. Yeah, so it's still effective. The other thing that you can use this for that I haven't really spoken about yet, I made this game ages ago using a very similar, very similar system, where I basically just put like heaps and heaps. I wonder if we can do it. Let's just see if we can do it. I don't know if this is going to work now. I'm just going to put a bunch of players in the game. And then I'll put that there. Let's just see if that works. Spread the planets out and make it more so it's more space and less fighting. Let's just see if this works. I'm not 100% if having multiple players in this build will work. We might have to shift the code around, but you can kind of see basically how this mechanism works. Oh, it is working. Cool. I think we've lost a couple of them anyway, though. You can still see that they are, in effect, moving within gravity, though. Anyway, you guys get the idea. That is how we do circular gravity in Game Maker. As I said at the beginning of the stream, an archive of this stream will be available on Patreon for anyone who wants to go and support there. The video will come out on YouTube in the next week for free for everyone, as well as the project files will be available for download on the Patreon post. I'll leave a link in the description when that comes out in the future. So I want to say thank you guys for watching. I hope you've enjoyed this stream. If you have, well, if you're watching in video form in the future, please leave a like and subscribe to the channel. That's help me grow, help the channel grow, and we'll be back with another one shortly. Take care, everyone. I will see you guys later.